29, which compound is chiral and reacts with sodium carbonate to give you CO2? So we're looking at carboxylic acid. So it must contain carboxylic acid. This is not carboxylic acid. It can react with sodium, okay, but it does not react with carbonate because this is not acidic. You have not an acid there. There is an ester. If you are not sure, draw it out and convince yourself, okay? This is an ester, something you have done since GCSE and O-level. So there's your carboxylic acid, but no chiral center there. Chiral center is not to do with cis and trans, yeah? It's to do with your carbon bonded to 4 different groups. One, another one to hydrogen, another one to bromine, another one to CO2H. Question 30. So these are all esters. You want to hydrolyze the ester. You want to give propanoic acid and propan-2-O. This is a 3-carbon carboxylic acid. This is a 3-carbon alcohol, but be very careful. This is the 3-carbon carboxylic acid. This is the 3-carbon alcohol, but it's propan-2-O, so it's a branch alcohol, yeah? So first of all, we can try and imagine you breaking them like that. The bit with the CO2, this bit is the, so if I just shed them, this bit is the acid, this bit is the acid, this bit is the acid, this bit is the acid. So the acid is the blue shaded bit. We are looking at 3 carbon, 1, 2, 3, so that one is fine. This is the branch bit. That one is not fine because your branch is the alcohol. This is 1, 2, 3. Again, the acid bit is fine. This is 1, 2, 3, 4. This is a 4-carbon acid. This is not fine. All right. Cross out 2 options already. Now you're left with 3-carbon alcohol. Let's try a different color, green. So here you have 1, oops, sorry, I don't want that actually. I want a green color ink. 1, 2, 3, and 4. There are 4 carbon alcohol. You can cross that out, okay? You only have 1, 2, 3 carbon alcohol because propanoic acid, propan-2-O, 3 plus 3 is 6. 1, 2, 3, 4, 5, 6. Here, 1, 2, 3, 4, 5, 6, 7. Okay, I'm sure you can count that. This is the typical kind of section B question for this Cambridge International A-Level. So that tests your understanding and your logical thinking. So going through the options, you will realize that we always go through number 2 first, because by default, if number 2 is incorrect, you're left with this, all right? And then we check for number 1, and then we check for number 3. The correct here depends on what they are asking. Sometimes it's a negative statement, sometimes it's a negative things that they're asking, all right? So be very careful. And sometimes they do say which one explain this thing. So you could get a correct statement, but it doesn't apply or it doesn't follow with whatever they want you to think about in the context of that question. So you need to be very careful with your reasoning and understanding, yeah? So let's get started with this question 31. So you have an isolated gaseous atom. You have paired electrons in at least one of its 3d orbitals, but it also has a field for s subshells. Okay, so what can we say? Well, let's do gallium first. Gallium is your, excuse me. So go to your periodic table. So gallium is in group 13. So gallium is starting from argon. Then you fill in the potassium and calcium is 4s2, and then 3d10, and then 4p1. Okay. You have paired electrons in at least one of its 3d orbitals, where you have completely filled 3d orbital. So we can talk about paired electrons in at least 3d orbital, and then we also have a field, okay, 4s subshell. So filled there refers to fully filled, all right? So we look at the configuration of gallium then. we have a fully filled 4s subshell. So that is correct for gallium. So gallium, iron, and copper, we are referring to the atom, yeah? Atom. And how about paired electron in the 3D? As I mentioned, they have completely paired electrons in at least one of the 3D orbital. Here is paired in all the 3D orbitals, yeah? How about iron? So looking at the periodic table, iron is argon, 4s2 for potassium and calcium. Then you have 3d6 because you are in group 8. So 2 plus 6 is 8, all right? You don't have some special half shell stability or anything. So here you have 4s2. Your 4s subshell is completely filled. Because you have 3d6, you have parallel spin first, and then you will pair them up. So you do have paired electron in at least one of the 3D orbital. Okay. How about copper? Copper is argon. Sorry, start from argon. Then 4s2, 3d10, and then not 3d10, 3d9, because 2 plus 9 is 11. But you also know that copper is one of those, is copper and chromium, okay, that has a weird electronic configuration where they prefer the electrons to be paired up in the d subshell, in the d orbital, sorry, compared to in the 4s orbital. So instead of 4s2, 3d9, you will have 4s1 and 3d10, where you still have 1 plus 10, giving you 11. Okay, you're still in group 11. But now, because this is the more stable ground state. Okay, ground state meaning is the lowest energy for the gaseous atom of a copper. Alright, so 4s1, 3d10 would mean you do not have filled 4s subshell, because this is one of the confusing thing. This is the adopted electronic configuration due to the half shell stability or the full shell stability, okay, of having the electrons in the d orbital. They repel lesser than pairing them up in the s orbital. So although you do have paired electrons in all the d orbitals, but you don't have the filled 4s subshell. So 3 is excluded, 1 and 2, that means you only have option 1. Next bit, which allotropes of carbon have a giant molecular structure? So C60 is simple molecular. It exists as a discrete molecule. It's part of your case study under state of matter. Okay, so this is not giant molecular. Diamond and graphite is giant molecular. So there's option C. 33, which statement about endothermic reactions are correct? So in the endothermic reactions, your energy of product is greater than the energy of reactant. Okay, that means when you have energy profile diagram, you have reactants, and there is your product. Your reactant have absorbed energy from the surrounding. That's why your enthalpy change is greater than 0, because your product have more energy than the reactant. So transfer energy from the surrounding to the system, because the system absorb energy. It absorbs energy from the surrounding. That's why your product have higher energy than the system, than the reactant, sorry. So 2 is correct. Number 1, on the reaction pathway diagram, the products are lower than the reactant. That is incorrect. For endothermic reaction, it has to be higher. So 1 is incorrect, and 2 is correct. So that means you're left with C being the only correct answer. And we know the total bond energy of the reactants. It's greater than total bond energy of the products, because when we talk about reactants in the gaseous state going to product in the gaseous state, we can talk about their atoms. When we break all the bond energy, this bond energy of the reactant, and then this is bond energy of the product. Okay, and we can use Hess law. So the enthalpy of reaction is equal to the sum of the bond energy of reactant minus the sum of the bond energy of the products. assuming that they are all in gaseous state, yeah? And that is greater than 0 because we know that was endothermic. If that's greater than 0, so I could move this to the other side. So I could establish that this thing must be greater than the sum of the bond energy of the products. And that is exactly what it says. The bond energy of reactant is greater than the bond energy of the product. This inequality is obtained by looking at this Hess law relationship. But of course, if you can work out 2 is correct, 1 is incorrect, you already know that 3 must be correct by logic. Question 34. So you can increase the rate of a chemical reaction by using a catalyst. For which reaction can a heterogeneous catalyst means it's a different phase than the reactant. Your reactant both are gases here. You use iron, solid, finely powdered iron as a catalyst. Solid is a different phase than the gas. So what you have is a heterogeneous catalyst. 1 is definitely correct. We use V2O5, which is a solid. It's a transition metal oxide. It has got giant ionic structure. As you can imagine, vanadium 5 plus and O2 minus. This is gas and gas. It's not solid. So obviously there's heterogeneous catalysis again, yeah? And in here you have rhodium, palladium, platinum, which are all solid catalysts. These are precious metal catalysts in the catalytic converter. These are gases. So these are again heterogeneous catalysts. So all 3 are correct. 35. So you want to see which chlorides can produce a solution with a pH of less than 5. So that's very acidic. Alright. So both the SiCl4 and LCl3 will produce HCl upon hydrolysis. So we're going to get pH 2, we get pH 3 there. So even though they produce HCl, but this is hydrolyzed, it's not as easily hydrolyzed as that. But essentially if you write pH 2 for the resulting solution, it would have been accepted as well. This is a pH 6.5. It's only very, very weakly hydrolyzed. If we think about it, you have MgH2O, 6 of them, and then in the presence of water, what you can do is you can get this equilibrium where you get H2O, 5 of them. Now one of the water loses the H plus. Now you have OH minus and Mg2 plus. You have a plus and you get H2O. What is important is this is an equilibrium. So it favors not very much to the right hand side. So equilibrium therefore only weakly acidic, pH 6.5. Alright. So only 1 and 2 will give you strong acid. So that is option B. 36 is a question on acid rain and environmental chemistry. So you can catch through a lot more of these environmental chemistry stuff under the topical playlist of nitrogen and sulfur. If we check number 2, so acid rain causes an increase in the concentration of heavy metal ions. So your acid rain introduces acidic component. Okay, so this is a bit tricky. This is a bit tricky because we are not sure about this. What is this, right? I mean, acid rain usually just gives us acid. But what is this about heavy metal ions in water causes? So let me just check 1 and 3 as well. Acid rain is formed when you have oxides of nitrogen, oxides of sulfurs, reacting with water in the atmosphere. So that's definitely correct. Number 3, this is about SO2 to SO3 in the atmosphere. This is not the man-made contact process. This is different, alright? So this is not an equilibrium because this happened in the atmosphere. The NO2 reacts to give you NO and you get SO3. Sulfur get oxidized to sulfur plus 6. This is sulfur plus 4. This is nitrogen plus 4. It get reduced to nitrogen plus 2. What it means by catalyzed there is because the NO there reacts more with oxygen to give you NO2. you regenerate. Okay, regenerator. So these two equations shows the overall catalysis of what happened with the NO2 catalyzing the SO2 to SO3. So we know that is what happened in reality in the atmosphere. Okay, so in the atmosphere, this is not equilibrium because you are not in the contact process. All right, so 1 and 3 are correct. So that means 2 must be correct by logic. All right, and by the option that we've been given. Which compounds contain a chiral center? If I start by drawing number 2, I have butanoic acid. Nope, there's one carbon short. 1, 2, 3, 4. Okay, down there's one carbon low. Ay. 1, 2, 3, 4. So that was right all along. So there was 1, 2, 3. So I get an OH. And I hope you can see there's a chiral center there. Okay, so this one is for that. 2 is correct. How about when it's 2-hydroxybutanoic acid? So I get butanoic acid. 1, 2. This is also chiral. So 1 is also correct. 4-hydroxybutanoic acid. What does that mean? So this is position 1, 2, 3, 4. Well, there's no chiral center because it's CH2, 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 and this is a carbon sp2. So only 1 and 2 are correct. Question 38. This is a monomer used to make polyvinyl chloride. So this one you have learned since O-level in GCSE. Assuming that one particular molecule of the polymer forms from n molecules of the monomer, which statements are correct? So if you have n times this, you will get CH, H, HCl, the carbon form 4 bonds, and there is no other byproduct because this is addition polymerization. Okay, so addition polymerization is not like condensation polymerization. You do not get any other byproduct. Okay, so the empirical formula for the monomer is the same as the empirical formula for the polymer. So if we look at that, there are n chiral carbon atom in this polymer molecule. If I have n molecules of the monomer, I will have n repeating unit of these, and each one of these has a chiral carbon because, or carbon hydrogen Cl. This number here is different from this number here, so that is chiral. So therefore we are looking at n chiral carbon atom in the polymer molecules, and that is precisely correct. Okay, so let's check number 1. The relative molecular mass of this polymer is approximately, so they're not saying exactly. Where did I get 62.5? Well, check the molar mass of this. Check the molar mass of this. There's MR of C2H3Cl. That's equal to 12.0 times 2 plus 3 times 1.0 plus 35.5. That gives me 62.5. I have n number of this monomer in this polymer, in this one n molecules of the polymer. So I'm looking at the relative molecular mass being 62.5 n, and that is precisely correct. Okay, there are 5 n sigma bonds. All right, let's count the sigma bond here. So you have 1, 2, 3, 4, 5, 6, and 7. In one repeat unit, you have 7 sigma bond. So it's not 5n, it's 7n. In one repeat unit, you have 7 sigma bond. So when you have many repeat unit, you will have 7n sigma bond. Okay, because you got to count the one that extended to the end as well, because you lose the double bond. So it's no longer 1, 2, 3, 4, 5 sigma, but you also extended the other end because you have added across the double bond, carbon from 4 bond, added one there, added one there. Okay, so 3 is wrong, so 1 and 2 are correct. Question 39. So you have an organic compound with this skeletal formula. You want to know which one is correct. X will dehydrate, so that's minus H2O, to a single alkene. Well, this is the OH. we need to remove the H from the next carbon. The next carbon only has one hydrogen. So when you remove H2O, there's only one option for you. There's only one alkene because no cis or trans, and also no other carbon, no other neighboring carbon with a hydrogen. So 2 is correct. X is a primary alcohol. Well, the carbon with the OH is bonded to one other carbon. Primary alcohol. Correct. X will undergo substitution with chloride ions. So you know how you would normally replace it to become that, okay? Typically we would use SOCl2 or PCl5, okay? But then there's also other cases where you use HCl, okay? You can use concentrated HCl, and there is a source of Cl minus. Essentially you need to reflux it a lot, but it can undergo a substitution reaction if you have that, because that is a potential nucleophile and with a lone pair, okay, and that can attack that carbon, which is delta plus and delta minus. But it might not be as easy as OH minus replacing the halogen alkane, but you can potentially do it if you have a lot of these nucleophile around compared to this, and if you are in a reflux condition, you can do it, okay, instead of using this. But these are the conventional, easier method, because this one you can just do a room temperature. This one you have to reflux it. Room temperature, because these are very exothermic, very reactive, very fast. So all three are possible there. This is question 40. This is the last question of this paper 1 tutorial. So you have trimethyl pentanal, start from the name, 5 carbon, 1, 2, 3, 4, 5. It's a pentanal, it's an aldehyde. So draw an aldehyde. And then it's a 2, 2, 4, and it's trimethyl, so it's 3 times CH3, 2, 2, 4. Okay, so there's the compound there. So what do we have? We have an aldehyde. So I hope you can see that you have an aldehyde. So aldehyde can react with tolerance reagent. You will observe silver mirror, because the tolerance reagent will go from AgNH3 twice, so this is colorless. It will go on to form silver because this is reduction. Silver plus 1 because this has no charge, so the plus 1 refers to the silver. This is silver 0 because you form silver mirror, because the aldehyde get oxidized. Alright, 2,4-DNPH can react with the aldehyde. Okay, again, so you will get an orange PPT, and it's a condensation reaction. A lot of students don't know this reaction, but essentially this is what you form. This is the condensation reaction. So you form that. I can draw this easily, but again you should be able to, because this is part of your AS syllabus. This is an orange PPT. This happens at room temperature with 2,4-DNPH to give you this orange color precipitate, crystalline precipitate. This is a condensation reaction. You lose the oxygen, you lose the 2 hydrogen on the hydrazine. Okay, alkaline aqueous iodine is a test for CH3 CHOH or CH3 C double bond O. You do not have CH3 CHOH. You do not have a ketone, because this is a methyl ketone. You'll have an aldehyde. So 3 is incorrect. Only 1 and 2 are correct. Okay.